Welcome to part 2 of solving radical equations. If you haven't watched part 1, I recommend you go back and watch that part first to understand the basics of where we're starting from for this video, because we're going to be doing some of the same type of work this time, but it's going to get a little bit different because we're no longer strictly working with square roots. We might have cubed roots and we might have roots to other powers. So, watch part 1 if you need to. Otherwise, let's get started. For our first example here, take a look at it and notice if you see anything different from the examples we did in part 1. Hopefully, what you notice right away is the fact that both sides have a square root this time. And the only thing that changes is the look of the problem. Just like before, we want to get our t's by themselves. So we're going to have to square both sides just like before. And all it does is take away the radicals from both sides. So we're going to end up with 2t minus 7 equals t plus 2. And now it looks like a regular algebra problem. We got to get all our variables on one side, all our constants on the other, and then solve. So if I subtract t from both sides, and if I add 7 to both sides, well, all I'm left with on the left side is 2t minus t, which is 1t, and on the right side I'm left with 2 plus 7, which is 9. Now, being good mathematicians, plug it back into your original equations and see if they equal each other. So we have the square root of 2 times 9, which is 18 minus 7, so we get the square root of 11. And on the other side we have the square root of 9 plus 2, which is the square root of 11. So since both sides equal each other, this is the true solution, t equals 9. Not too much different from what we did in part 1. So let's throw something new at us. At first glance, this new example looks just like the ones we've been working on, but hopefully you notice our index. Our index is 3. Which means this is not a square root, this is a cubed root. So this is the cubed root of 4x, and we want to figure out what's going to make it equal to 2. Well, think of it this way. When we had just a square root, our index for a square root is 2, so we raised both sides to the second power. But since now we have a cubed root, if I want to undo this and get rid of it, I have to raise both sides to the third power. And that is how we cancel out a cubed root. So this will go away and we're left with 4x. And then we have to think of what is 2 to the third power. Well, 2 to the third power is 2 times 2 times 2. 2 times 2 is 4. Times 2 gives us 8. So we have 4x equals 8. And then if I divide by 4, we get our answer of x equaling 2. Being good mathematicians, we plug it back in. So we have the third root of 4 times 2, and we want it to equal 2, hopefully. 4 times 2 is 8, so the third root of 8, we want it to equal 2. And well, we kind of proved it with our work up here. 2 times 2 times 2 gave me 8. So the third root of 8 has to be 2. So 2 equals 2. And that is our solution. X equals 2. Checking our work can really help us as it can prove whether or not we've done it correctly. Alright, let's move on. Let's try some more. Alright, now we have 4z minus 1, that quantity raised to the 1/5 power, minus 1 equals 2. This one looks a little ugly. Not going to lie to you, it looks a little ugly, especially because of our rational exponent. But remember, this is the same thing as the 5th root. So if you prefer working with roots, you could rewrite this as the 5th root of 4z minus 1 equals 2. So if you want to rewrite it like that, be my guest. It's not going to change how we approach the problem, but if it helps you, go for it. So I want to get this quantity all alone, so I got to get rid of this minus 1. And if you think back to your algebra, you have to add 1 to both sides to make that happen. So we are now with, I'm going to go back to writing it the first way. We are with 4z minus 1 to the 1/5 power equals 3. And I just realized I wrote this wrong. This should have been a plus 1. 2 plus 1 gives us 3. All right. Now, I have to get rid of this exponent, 1/5. So I want the exponent to become 1. How am I going to do that? Well, I'm going to raise this whole thing to the 5th power, which is exactly the same thing we would do if it was written like this. Because if I'm raising an exponent to a power, we multiply them together. 1/5 times 5 gives me 1. And since I'm doing it to one side, I have to do it to the other. So we are going to have now 4z minus 1 without the parentheses because the exponent has been undone equals 3 to the 5th, which is 3 times 3 times 3 times 3 times 3. And if you don't have a calculator, well, 3 times 3 is 9, 3 times 3 is 9, and then we've got a 3 over there. 9 times 9 is 81 times 3, and then we can finally get it down to 243. So 3 to the 5th gives us 243. Now, I want to get z alone. I want to get this guy all by himself. And it looks just like a basic algebra problem. I have to get rid of this constant, so I'm going to add 1 to both sides. I have 4z equals 244. And then to get z all by itself, we get rid of that coefficient. Since it's multiplication, we divide. And we end up with z equaling 61. All right, so if I plug all that back in, so I can check my answer. Let's erase some of the stuff on the right side, so I have some room to check. If I rewrite the problem as, oops, didn't mean to undo. Let's erase this again. So, I rewrite it. Since z was 61, we have 4 times 61 minus 1 to the 1/5 power. Minus 1 equals 2. Well, we just said 4 times 61 was 244. Minus 1 is 243, so we have 243 to the 1/5 power. Minus 1 equals 2. And since we worked this out already, we know the 5th root of 243 is 3. If you're not sure about that, check it on your calculator. So the 5th root of 243, or 243 to the 1/5 power, is 3. Minus 1 equals 2, and 2 equals 2. There is our final answer. So x, oops, not x, this problem was in terms of z, equals 61 is our solution. All right. I feel like that's pretty good on these. You should hopefully have a good understanding on how to handle these types of radical equations now that we have different exponents or different roots. And then there will be a part 3, which I hope you check out, which means we have to talk about inequalities. So hopefully I'll see you at part 3. Good luck!